All right, let's look at the homework 8, problem number 21. All right, so we want to find the dimensions of a rectangle with an area of 64 square feet that has the minimum perimeter. All right, so gut feeling tells you that the most efficient shape would be a square if you choose from a rectangle. So it's going to be probably 8 by 8, but let's try to do it mathematically. All right. So we know that area has to be 64. So let's say you have a base is x, the height is y. So we have this condition: x times y has to be fixed at 64. All right, and we have a perimeter. P is equal to, all right, so you have a 2x's and 2y's, so it's going to be 2x's plus 2y's, right? All right, then we want to look at it as we don't want to deal with two variables at the same time. So I'm going to eliminate one of the variable. So I'll probably eliminate y here. So we know that I'm going to divide through by x so that we can solve for y. So y is equal to 64 over x, right? Then we can just plug this guy right here. Right, so this is going to be 2x plus 2 times that, 2 times 64, 64 is 128, so 128 over x. Right. So we have a p function, a perimeter function, and it's in x. So we want to minimize, this p function. So I'm going to call it the p of x, which is 2x plus 128 over x. And we want to minimize it over. X has to be a length, so you cannot have a negative length, and it cannot be 0 because 0 times anything is going to be 0, so it'll never get 64. So it's going to be at least positive. And x could be as big as we want, because if x is huge, we can set y to be very, very small, so that the area is still 64 square feet. So I'll just put over from 0 to infinity. All right, so we got that. All right, so let's try to find the absolute min over this interval. All right, so critical number. We're going to take the derivative, so p prime of x is equal to, derivative of 2x is 2, Maybe before that, I'm going to rewrite this guy, so I don't like a fraction here, so I'm going to look at it as a 128, then we have x to the negative 1 power, right? So derivative of that would be, let's see, you have negative 128 and x to the, subtract 1 from the power, so you have negative 2. All right. Then let's see, we want to set it equal to 0, but before we do that, maybe I'm going to pull out the 2. So pull out 2. All right. Then you have a 1 minus. Pull out 2, so you have 64. Then we have x squared on the bottom. So this is, so then I'm going to take the common denominator. So let's see, take the common denominator, which is x squared. Then you have x squared minus 64. So we can easily factor this one out. So 2 is already there. So if you factor this out, you have x plus 8 times quantity x minus 8. Then we're going to divide through by x squared. We set that equal to 0. So we know that here x is going to be equal to, right? We set the numerator equal to 0. It's a positive plus or minus 8, right? And if you do a number line starting from 0 to infinity, right? So it's starting from 0, and only critical number that goes on this interval would be positive 8. So I'm going to put the positive 8 right here. Then we're going to look at the derivative. So p prime. All right, we're going to do a sample number. So anything between 0 and 8, I like 1. Right. If you plug in 1 in here, you have, let's see, we can use either of these. Here, you have 64 over 1 squared. So 1 minus 64 is a very negative. So you have a negative value right there. All right. And we can try any number bigger than 8. I'll try 9. So you have a 9 squared, which would be 81. So 64 over 81 is less than 1. So 1 minus that would be positive. So you're going to have a positive value right there. Right? Which means that the p function is going to be decreasing before 8 and increasing after 8. Which means that we're going to have absolute minimum at 8. So I'm going to say I'm going to just say minimum, right? Minimum is going to happen right here. All right, so let's go back. So it's at 8. So dimension of the rectangles are 8 by 8. So I'll probably do 8 by 8. Let's see. Use comma to separate answer needed. Maybe 8 comma 8. All right, let's see what it says. All right, we got that. All right, that's it. I hope that this was clear.